So I'm Adarsh Ramakrishnan. I'm a local community member. I run the product development firm Elegant Solutions. I've been doing that for the last 3 years. I'm also a former WHO. Graduated from Mechanical, Aerospace, and Materials Science in 2012. I still hang around the engineering school because my company contracts with the Engineering and Society Department, and as a result of that, I'm a curriculum assistant where I help the engineering department build programs related to design and entrepreneurship. Alright, so the first thing when you're setting up a new file, you want to pick what you're going to be working in. So I usually like metric, unless I'm dealing with a specific problem that requires me to use English system. And then you have plenty of different options on what kind of a part you want to start. Now, sheet metal modeling versus standard modeling, the biggest differences there are you get some additional functions in sheet metal modeling, where you can bend, you can kind of flange, these different functions that are only relevant for sheet modeling. So typically what you're going to go with is a standard millimeter .ipt. .ipt is the file extension for a part file. So let's go ahead and create one. It's doing something. Look down at the bottom, there's like a little loading bar. That's how you know that you're not frozen here.
What's the difference between for the standard model, their response is DIN and their response is
DIN. Yeah. So
DIN
is a standards, it's kind of like ANSI. It's a standards, oh man, what would you even call it? I want to say a standards board. But it's kind of like a standard specification. It has a lot of relevance. DIN rails are what you'd hear you'd hear or have heard kind of in casual parlance. But it does have a specific use. I personally have never had to use it.
Okay.
I know situations where you would when you're building like a junction box, for example. You'd have to use a DIN rail, and that's when that stuff comes into play. But for the sake of what you'll be doing, standard millimeter parts are what you want to go with, or inches if you have to use English. Okay, so now we're in our environment. Just giving you guys a quick overview. Right here are your view controls. So your zoom is this, your pan is this. This is the orbital rotate, so that's how you rotate. Typically you use pan and zoom and then rotate once you've finished your model to make sure that it's looking good. And the most important button is in the top left. It's create a 2D sketch. So let's go ahead and click that. And now you're set up with your planes. So you've got all of your different planes that you can create a 2D sketch on, and I get to select which plane I want to work with. So I'm going to go with the XY plane right here. Just keep it simple. Okay. And now it's going to zoom me in and give me a sketch. So now I'm in sketch mode. You'll notice up here things have changed. So we're going to go ahead and do a semicircle. And also I want to expose you guys to a quick, not even a quirk, but really a design consideration that you can make when you're drafting in CAD, which is to build a semicircle in a 2D sketch. There are a lot of different ways you can go about this. You can use the arc tool. You can use the circle tool, you can use, really if you wanted to, you can use the line tool and then build a spline off of that. So there's a lot of different ways to approach it. Now, with CAD, my general philosophy is draw it the way you draw it by hand. That's kind of how I like to think about which way to go about doing something. So when I'm drawing, a semicircle, for example, I'll draw a full circle. And then I'll go through and I'll erase the rest of it. That just makes more sense to me, because if I'm drawing a half circle, it usually gets kind of stretched out if I stop halfway. So maybe even I won't draw the entire bottom part of it, but I'll draw a full circle and follow through with the motion. That's how I personally think about it. Now different people do it in different ways. Some people have a better hand than I do. Some people prefer to actually draw two endpoints, like my business partner does this, draws two endpoints and then connect them with a curve. Lots of different ways to think about it. Pick the one that you're most comfortable with. So we'll just draw a simple circle here. So click the circle tool, select a center point, and then you can drag out or you can directly input a number. Now, what would you guys say we should use for wrist? You know, about this much. What would you guys think that is in millimeters? Go ahead and estimate it.
50?
40.
50.
40, 50.
That's about right. That's what, at least I think my wrist is about 50. So now what I've done is I've gone ahead and drawn a circle. Great. I'm now going to have to make this into a semicircle, right? So what are some ways I can turn this into a semicircle that's still got the kind of like the two limbs going on either side? Does anyone have any ideas?
Draw a horizontal line to the outside of this,
Okay.
and then trim.
Okay. Anyone else? Okay. So there's a couple of different ways to do this. Remember that we want the center part to be hollow. So what you can do is either A, draw another circle that's either concentric or kind of outside of this. Now, if we want the inner diameter to be 50 millimeters, you want to set this on the outside of the circle that you just drew. So you can set this to then, let's say we want a 10 millimeter thickness, I set that to 60. So that's one way to do it. Another way to do it is to come here, and I'm trying to find the button on this one. There we go. So this is a really nice tool called a concentric constraint. And what you do is you simply click that, click a circle, sorry, this is, I'm having some problems clicking this just with the mouse. So click this, and then I click this guy, click. And now what's happened is if I, they actually already were constrained. But basically what that does is if I drew two circles that weren't sharing a center point, it would force them to share a center point regardless of where I move things. So that's a good way to make sure that your circles are actually lined up. And this comes more into play when you're using like several different types of circles within one geometry. Like for example, a planetary gear system, you'd want to do something like that. Another way is to create an outline. Let's see where the button for that is here. So it's called an offset. Okay, got it clicked. See if tapping this works better. Yeah, there we go. Now, when I create an offset, what that does is it will take the geometry, and this works actually for even more complex geometries. So if you have some crazy polygon that you want to create a thickness on, you can use the offset tool for that. And then I just pick how long I want to make my circle, or how small I want to make my circle. And once I click, there you go, created a circle. Pretty easy. And then of course, you can use some of the other tools. I'll let you guys play around with those on your own, just in the interest of time here. So now, finally, I need to cut the bottom part of the circle off. So what we can do is draw a line connecting these two. Okay. And one thing you guys might have noticed there was it was saying like 64.57 millimeters. That's not clean. I mean, that just doesn't look good, and that'll get you in trouble down the road. So what you want to do to manually set the size of something once you've created it is if it already has a dimension, you can double click the dimension and then change it there. But if it doesn't have a dimension, A, give it one. So now I've put a dimension on here, and then B, change the dimension. So let's make that a nice 65. Small change, but it actually will help down the road if you want to make something out of this geometry or you want to use it for something more complex. Also, sometimes when you've already constrained something, you guys saw that error message already where it said this is over constrained, but you can manually go set one in, and what that'll do is it'll tell you, wait, you're trying to set a new diameter for something when you've already set a diameter for it in a different way. For example, let's say I start defining the curvature of this part of the circle. It's going to tell me, no, you cannot do that because you've already said that this is a circle with the dimension 65. So that's kind of a nice thing that Autodesk does for you and lets you know, and it's a good sanity check, you know. Even if you know something is going to be over constrained, try constraining it just to make sure that what you thought was real is real. All right, so now we've got a good profile. We've got some options here. We could trim this in this view, but I personally don't see a reason to trim unless you really want to. Instead, what I like to do is just let this get taken care of in the 3D modeling view. So now we come here, the second most important button on the right, which is Finish Sketch. Click that, and we've got a 3D sketch here that we can now do something with. Okay, so I mentioned extruding, that's pushing or pulling. That's what we're going to do. So I click Extrude, and then I can select a specific profile that I want extruded. Actually, I'll show you guys cutting as well. I'll do that with the same view. So we'll use the outer view. I was going to go back in and reconstrain the points because sometimes, so if I'm just trying to select that inner circle right there and just the top part of it and it's not selecting, what that tells me is I need to go back into my sketch and constrain points for this point right here and this point right here. But instead, you know, what I'll do is I'll just leave that for now. Select this, and then now it's asking me by what length do I want to pull it and which direction do I want to pull it in. So you've got a couple of different options. You can pull it in the positive axis, you can pull it in the negative axis, you can pull it symmetrically across both axes, or I can pull it asymmetrically across two axes if I wanted to. I'm going to go ahead and make this simple, pull it in one direction. How big do you want this band to be?
Like his watch right there.
Okay, so do you guys think
two centimeters maybe?
Okay, two centimeters? Pardon?
I mean,
20
that's
millimeters?
Right. Okay.
it's just shy of an inch thick.
Yeah, I think that makes sense. We're right. Yeah, you're right.
20.
Yeah, let's make it 20. So, hit OK. And boom, you now have a solid model. So solid models are what are the kind of end game in Inventor. 2D modeling is a means to get a solid 3D model. So that's the way I like to think about it. Now, you can rotate this guy using the rotate tool and get different views of it.
Now, how would you subtract out the middle of that?
Okay,
Yeah,
that's exactly where we're going next. So you've got a solid model. Now, just like you said, you want to cut parts of it out. You want to make the center part hollow. You might want to actually, tap into it with a hole like you wanted. So we're going to do all of those things. Now, that sketch that I just made is still there. It's hidden, but it's still there. Okay. I clicked. Okay. Why isn't this? I don't know why it's doing that. Okay, maybe that's a new feature. Typically you have to turn visibility back on to see it. Ah, here we go. I don't know what it was doing just now, but you see visibility. So when I right click the sketch, I want to right click it and I want to turn visibility back on. So now the sketch is showing up again, right? And I'm going to want to see the sketch from behind. So right through there. And now I want to cut through it. So I want to take this section of it in the middle out, right? So what I can do is go right back to extrude, and then, there we go. Can I even select this? I saw it flash for a second. Maybe not. Okay. So I want to hollow that part out, right? We're cutting right through. We're making this into the top half of an armband. So I'm going to go ahead and select this, and now I'm going to use this selection right here. So in this tool, we were joining. Now I'm going to use cut. So I select cut, and now cut works the exact same way as join, except it's going to remove material in the direction that I'm saying. So I'm going to cut in 20 millimeters. And then if I hit OK, boom, I've got that. Now I can hide my sketch. I mean, I don't want to see that anymore. And we've got something that looks exactly like what I drew up there, right? So we're getting a step closer. Now, finally, the thing that we wanted to add were slots for the pins and bore a hole through the center, right? So we rotate our model. And now this is where that kind of 3D logic comes into play, where you're dealing with an object in a 3D space. So you need to find a way, if I want to get to this point, the center point of this located this far up from the base of the pen, I can't just move there and then cut in with a plane. What I need to do is set up a plane here and then move that plane in. So you can't just draw a plane through the center of an object. You need to pick an endpoint, pick a surface, and then progress inwards from there. So what we can do is create a 2D sketch. So we come here, and then I'm just going to go ahead and select this leg right here. Okay? And we want to bore holes, right? So I'm going to select a circle. And if you guys can see this, there's faint dotted lines. That kind of is the snap to feature that's just showing, hey, you're at the center point of that geometry. So I'm going to go ahead and draw a circle. Let's go ahead and make this 5 millimeters. Okay? And then I can do the exact same thing on this side. You can again see that it's got a, actually, here, I'll use this as a teaching point. So it's got a dotted vertical line constraining it to the center point of that, but I don't know where it is there, because I drew the 3D plane on this surface, not on that surface, right? Oh, it's a touchscreen. So I know that this is on that surface and it's at the center, and I can make this a 5 millimeter object, but I don't know where this point is and whether it's at the center of this shape. Well, I guess I kind of do. Okay, well, that's cheating. But at the same time, what I wanted to show you guys is I can dimension from there to the center point. And that's going to give me a reading, right? So now I know that the entire length of this is 65. And if I want that at the middle, I'm going to take 65, knock off 2.5, right? Because we made these, did we make these 5 or 15?
5.
But we also put a 5 on the outside.
It might be 10.
If it's 65 and we made the inner 50, so that's going to be 15. So 15 and a half. So 7.5. So each of these are 7.5. Does that add up?
Yeah.
Right, okay. So the center of 7.5 is what? 3.75? Is that it?
Yeah.
Okay, so 3.75. So I'm going to knock off 3.75 from 65. So you have to do a little bit of mental math here. So that gives me 61.25, right? So 61.25. Sure. And now you've got, okay, this is now properly constrained. It's at the center of that rectangle, and it's got a good geometry, right? So the final thing that we wanted to do was drill a hole through the middle. Let's say we want that to be, I don't know, 50 feet. Or, I'm sorry, 50 millimeters. Wouldn't even work. That'll cut the thing in half. So let's make it 15. So there we go. Once again, you can see the guides kind of telling me, okay, I'm at the center of this, between these two things. Let's make this 15. So you got a nice big place to put your watch face or whatever you want. Okay? Then now finish up the sketch. And the exact same process that I showed you before, except now you're going to be selecting multiple profiles. So I select this profile, and then I select this profile. I'm going to make them cuts, and I'm not going to make them 20 millimeters, I'm going to make them, I don't know, 5. We'll make them 5 millimeters. Okay. And my sketch disappeared. So I go to my extrusion, right click, turn visibility back on, extrude, select this, making a cut. So the height of this thing plus whatever I want to bore into it. So 25 plus, let's say we want to make this go right through. So 25 plus 7.5. So that is, what, 32.5. Right? So 32.5, boom. And now you've got a full band with the holes tapped into it. And also you might notice this hole feature up here. I could use that as well to make these holes. And the nice thing about using that, especially if you're trying to use some sort of a connector, so let's go through here and then
A quick question for you.
yeah, go
When
for
you're
it.
extruding like that, does it matter if you get it exactly on the surface, or can you just like extrude over? Like say like you put 7.5, like if you put in 10, does that matter?
No, it'll cut right through.
Okay.
However, if you put another geometry next to it, it'll cut into that.
Yeah. Okay.
So be careful about that. I could have chosen hole here, and then what you do is you want to select a center point. So I select a center point, for example this, and then if you notice, this gives you a lot more control. So going back to what I was saying about tang pins, you can put a head, you can put a tap, which is kind of for something called a countersink screw. You can define threading if you wanted to. You can really control what kind of a hole you're putting in there. We're just drilling simple circles, so you can use a cut, but I do suggest that you explore the hole feature if you're trying to actually use a fastener. So we'll just cancel this, and now you've got something that looks actually pretty useful, right? I mean, this is what you were kind of looking for. It's got a band, a hole, and then 2 pins to fasten with. So what you would do with this, you can 3D print it, and I guess we're a little bit out of time here, but what you would want to do after that is maybe print 2 of the same part, or print 1 part with the hole and 1 part without. I don't know if you need them on both sides, and then just put a fastener in, and then you can combine the 2 parts. And if you wanted to do that in the program, you would create something called an assembly, which I can work with you offline on if you really want to learn that. But, yep, sure thing. So I guess that's those are the basics. Did anyone have any specific questions they wanted to ask?
Is there anything useful? Like I know that there are some videos that are built in AutoCAD, but is there any like useful place to go or like things to look at if you want to teach yourself how to do those?
There's a site called lynda.com. It's relatively useful. They have some pretty good tutorials. YouTube is an excellent resource for this.
Yeah, I was gonna say YouTube.
There's so many good free videos on YouTube on how to do AutoCAD. Autodesk rather. I've always found most everything. I would say 90% of my Autodesk problems have been solved by using their help file. Because even when I hover over something, so if I hover over like hole, for example, which I just showed you guys, it kind of gives you a nice view right below it within the program. And then if I hit F1, it opens up the help doc, and that has a lot of really good resources. And they're all pretty up to date because they link kind of live. They update live, and it goes through very procedurally and says, hey, this is exactly how you do it. And then you can leave a question if you really need to. So yeah, that, and also just find somebody in the like mechanical engineering building that knows what they're doing. Grad students were the ones that helped me really figure it out, even more so than taking the intro to mechanical engineering class. Like car bodies and stuff,
Yeah,
you'd think Rhino or
that was one of my assignments, was to make a like a 64 Shelby Cobra.
Yeah.
And you can do it in like a day.
You can't do that in Autodesk Inventor as easily. Inventor is used a lot more for components and assemblies, so stuff like surfaces, I'm not even going to go over in Inventor because that would be doing you a disservice. It's possible to do it, but you don't want to use that for for surfaces. You want to use that for components and assemblies. Those are the two big things that Inventor is really, really good at.
So how do you, if I want to make a specific part, and then I want to make a different specific part, and then I want to put those together, how do I put them together? Like, how do I get Autodesk to have them put together in an assembly?
That's an assembly. So you just create an assembly file, and then you'd import those parts
Does it
in.
still work the same with Fusion?
So is this,
You just click
is this
Made in
Inventor,
surfaces?
Inventor Fusion, or whatever that is?
So Inventor Fusion is like the kind of combined suite, or a program that combines the entire Autodesk suite.
Okay, so
So-
should I open that? I'm just not really sure what
You want to open up Autodesk Inventor 2013 or 2012. There should be just one that's Autodesk Inventor. If you go to your